Thank you for being part of our first in-person event in 2 years here at New Lab. For those of you who know the community, we typically have had these type of events actually on a weekly basis, and not having people physically here for 2 years has been a substantial change for us, and it's so good to see a small, intimate group back. We have a couple hundred people also online, and we welcome them all for joining us as well. Thank you for being a part of it. Today, we're going to talk about actually a catalyst for me, which was reading Seek's report on deep tech investment and innovation. If you haven't read it, out of the lab, it's an incredibly interesting report. But there were 4 first page statements of conclusions that were so relevant to us and our community that we reached out to John and said, we've got to do an event and discuss this further. The first was assessing C-suite executives around the world and their admission that advanced tech was now a key focus and crucial to the survival of their corporations. For the first time, the S&P 500 has an average age of below 20 years for the corporate entities on that S&P 500. In 1960, the average age was 61 years. We've gone down to 19 this year. Companies are being disrupted by the technology being developed in startups, in corporations, in academia. And the first conclusion of that amazing report was that they have acknowledged they have to know what's happening in advanced technology, in deep tech, to be able to keep up and keep their businesses competitive. The second conclusion, which I loved even more, was that problems were driving the R&D tech, not just the tech itself. This wasn't R&D for no reason and search for an application. They were acknowledging that they had problems they believed frontier tech could solve. And when you looked at what technologies they were interested in, first was AI and ML, but quickly after that was quantum computing, robotics, biofabrication, a lot of other significant technologies that they are looking at to solve problems. And the final piece, which brings us back to New Lab, if you haven't been here before, was they admitted that the sources of these technologies were in academia, were in startups, were in competitive corporations, and even in government agencies, and that they now had to analyze and assess and find technology being developed in all 4 of them to remain competitive. And so where you're sitting today is within a community of 900 technologists and entrepreneurs here at New Lab across all of those technology fields we just mentioned. We're the Noah's Ark of frontier tech. There's a bit in AI and ML, there's some quantum computing, some biofab, it's all within this community. So the first acknowledgement was the type of talent we're building, the type of companies they're building are exactly what C-suite executives are focused on and are looking for. The second and final part, and then I'll hand over to the people who know more about this than I do, is that we run innovation studios for 15 different clients around the world, and they bring together academia, corporate entities, startups, and government to develop and pilot technology against problem sets. Exactly what the report said C-suite executives were looking for. So we brought people here together online and for the first time in person to discuss this further. And to start with, we'd like to welcome John Levy, the CEO of Seek, to the stage, along with Satish Rao, our Chief Product Officer, to start us off. Thank you.
I think the first step in thinking about a deep tech solution, and particularly quantum, would be to answer the question, why? Why is it that we need to do this? What opportunities are there? What gaps are there? What's high value? And what is simply impossible to achieve with classical computing? So we decided to commission a report around deep tech investing in large corporations to see what their interest would be in investing in things like quantum computing and how would they incorporate quantum computing in their own company. A lot of it was to validate some assumptions we had, as well as to answer some important questions. And we did that and discovered that people were identifying a very specific business problem they wanted to solve, and the fundamental fear that their competitors were doing the same thing and that they were behind. As time goes on and companies are beginning to publish results, the idea that quantum computing isn't just an academic theory, but is a practical reality is becoming more obvious by the day. Therefore, instead of looking like you're investing in research, it now looks like you're investing in development and markets. That's a signal that venture capital funds realize that when there is this opportunity to create whole new platforms, they can create whole new industries. And that opportunity Doesn't happen often.
Thanks.
Yeah.
It's great to be here.
Nice
It's great
to
to be
see
back
you.
at New Lab. Yeah,
You and I are back at it again.
I know.
Right.
Yeah, we did this. We did something like this during, deep COVID, but we were all, completely online.
And I think what we realized, we don't need questions. We just started. I had a bunch of questions for you, and it just turned into a conversation. So I think
Right.
that's
We
what's
just
going to
kind
be
of riffed
today.
on that. That was good. But it's great that we can be here, and I'm really happy to be here. And just for those of you who don't know, so SEEK stands for Scalable Energy Efficient Quantum Computing, and we're building a chip scale version of quantum computing, where essentially we take all of the functionality that would be in a quantum computer that typically operates at the temperature of space, so incredibly cold. And we figured out how to design a set of chips that can perform all the functions that you would need in, say, a regular computer, only it's a quantum computer. And we design those chips, we manufacture them in our foundry, and we integrate them into these circuits. And the circuits that we make are application-specific circuits to solve an individual problem for large companies. And that gets to why we did this, right?
Yeah, and I think that's what, when I was reading the report and seeing up there, the first stat that came up, it made my head whip back, because it's exactly what we try to do at New Lab in terms of working with corporate and government partners, is what is the challenge or problem you're trying to solve?
Yeah.
And what struck me was what Seek is doing, what I see deep tech happening today, is that finally the challenges are out there.
Yep.
They're surfaced, and people are realizing deep tech is the way to go. And that's why you're seeing more investment from the corporate side here.
Yeah, and I want to be clear that I just want to, hold on, I want to get a slide up here. When we did this report, we weren't just thinking about quantum computing. Of course, that's what we cared about, but we really cared about a broad area of technology. And by the way, it's, when we had this idea of doing this event, part of the reason why was because so many of the technologies that we were trying to feature in our report are, is based on work that's done here. I mean, even things like, climate change mitigation, drones, and people fly drones here all the time, 3D printing, renewable energy, there's a lot of AI work, and then quantum computing. And we were surprised to see what percentage of large companies were focused on quantum computing, and to your point, trying to solve a very specific problem.
Yeah, and being
Yeah.
sort of a recovering physicist myself over the last few years, like one thing I realized is that certainly basic research is important. You need to have people just inventing and trying to create new technology to be the platforms of the future. But to get the coalition that gets behind that and really puts it into the marketplace and puts it in users' hands, you need to have the mindset that Seek has. You need to have the buy-in from corporate, and you need to really understand that challenge. And I think those things are finally coming together in deep tech across a lot of these verticals that you're pointing to here.
Yeah, I mean, it's interesting. We actually tried to get, and Sean just mentioned it, we had 200 decision makers, and these were mostly C-suite people and senior managers of these companies, because we're trying to get into the headspace of understanding what their challenges were, why they were doing this. And one of the things that kind of came up is this idea of, here, I just want to put this up, is this idea of keeping up with competitors and to solve a business problem. And the funny thing about keeping up with competitors, of course, is you don't really know what they're doing. You know what they're hyping that they're doing, but from your standpoint, as you're in a large company, you're very fearful that somebody is going to eat your lunch with some new platform that they're developing. And you understand the problem set that they're working on because it's the problem set you have. So it's a really interesting set where you're also kind of gaming it and trying to figure out whether or not, is this real or not?
So I want to turn that back on you. That's a question. Now I'm going to interview you real quick here. So quantum computing, when it comes to R&D, highly competitive space. You've got billions of dollars pouring in at the research level in academic institutions, major corporate industry folks working on this, and of course startups. What is Seek's advantage there aside from the technology? Is it because you've got an eye on a specific challenge? You consider yourself more near term compared to other sort of trends there?
So we made a decision pretty early on that we didn't just want to create a a general purpose, if you will, fault tolerant quantum computer. I mean, let's assume for a moment that we could do that, but we thought that it was going to take a really long period of time. But what we really said was that if we could co-design a quantum computer with a software developer and a user, so let's just say a large company, that we could reduce the amount of quantum resources that we need and build out an application-specific device. It's funny, it's exactly how NVIDIA began. When NVIDIA began, they didn't build out, general purpose GPUs. They were trying to port a particular game from a Sega platform onto an IBM PC. And that's the problem they were solving. Well, by doing that, you're constraining the problem and you're constraining the resources that you can bring to bear to solve that problem. So our thought was, if we could do that, we could co-design and build a scalable application-specific platform that we could actually solve a near-term problem and not have to wait to get to the error-corrected, fault-tolerant, millions of qubits quantum computer that I think everybody would love to have, but may be years from happening.
Yeah, and I feel like we've seen this, let's say, maybe in an industry that's more broad that people might understand, which is the future energy transition, right?
Mm-hmm.
So where are we trying to get to in the world in 10 years or 20 years is net zero carbon emissions, full electrification of everything. But you can't just do that with one wave of the hand, right?
Right.
And so what can we do today with deep tech to solve some of the major problems in terms of carbon emission and carbon reduction?
Right.
And I feel like having that mindset of not saying incremental, but what's achievable
Yes.
on the way to the kind of the final win. I feel like this is happening in a lot of industries right now.
Yeah, and what's interesting about that approach is it's a way of kind of jump starting a market and building out a platform. Because if you can solve that incremental problem, you can solve, if we can, for example, model oxygen, O2, well, if we have a few more qubits, maybe we can model O3, which is ozone, and maybe that would be, doing an excited state and a ground state model of ozone might enable us to create some mitigation for the effects of ozone. So there are things that you can do incrementally where one leads to another, and where you can actually do something that's consequential while you're building out the ultimate platform that you need.
So do you think, there's a question back to you now. This is something I've got opinions on this based on the partners we've worked with over the years here at New Lab. Your stat on the executive level buy-in that's been required to sort of invest in these types of things. Why do you think that's happening now? Is it this realization that there is near-term goal achievements that can happen here? Or is it something else?
So look, that's a really interesting question because it requires some real courage at the corporate level. Because people are really sticking their necks out when they're going to, align with, let's just say, a startup, for example, that's developing an industry-changing or a generationally changing technology, and so we as the small company need that kind of champion, but it's very risky for them to do it. So the only reason they're going to do it is because they think there is a massive payout for it, and they think that they've defined the problem in a way where they can maximize the chance of success. Because, one of the things that we saw in this report is that the fear of failure, the fear of picking the wrong group, the wrong technology, the wrong time, et cetera, is sort of this countervailing pressure that works against this idea of, can we make a big leap? What's our competitors doing, et cetera. So it really is a bold step, and it also is risky for the startup, because if that champion, for example, leaves, or the company decides it has a new priority, then suddenly you're kind of on an island, and that's challenging as well.
Yeah, totally. And I think it's part of that. I'm picking up on something you just said there, which is about, am I picking the winner? Am I picking the right technology? And what I've noticed as well is there is a fear of understanding, how do I tell the difference between these two quantum computing companies? How do I tell the difference between these two carbon capture companies, these sensor companies, and so on? And it's funny because I come back to my roots in terms of experimentation in a lab. You can talk about it, you can pitch it, but you can't really understand it until you really test it. Yeah. And that's core to what we do at New Lab when we work with our industry and government partners and the startups in our communities. How do you get that deployment in the field and generate that data to test to create that buy-in? How do you, is that what's happening now for Seek as well? Like, how do you convince corporate partners to sort of buy into what you're doing?
So part of it is that we're actually, it goes back to this question about what problem are you solving? So one of the things that we're trying to figure out is, are we solving a problem which is a high value problem that's essential for that business? And have we reduced it so that it's actually achievable in a reasonable time frame? And from an investment perspective. And thinking about from an investment perspective, the other thing that we're interested in doing is aligning our investors with our success in solving that problem. So we want to have, in our particular case, we're not looking for 20 customers to work in, chemical simulation or something like that. We want one, and we want one who we are perfectly aligned with, and who, they want us to be successful in every way, and we want to be successful in every way. And then we bring them on as investors. So we've had this really interesting connection between our investor, community, if you will, and our customer community, where there's an excellent alignment.
Do you feel that you're in an industry where the trust is more in the academic startup side versus the corporate side? I go to this other stat about where the solutions are coming from, and I saw it was quite evenly distributed across, like
Right.
a third from corporate, a third from startup, a third from academic. It seems like I was very surprised by that distribution. In quantum, let's say, what are you hearing from the industry there?
Well, what's interesting about quantum is that in many cases, large companies have people who are actually trained in quantum physics or quantum chemistry. I mean, they actually have the expertise to understand it. So we are a deeply technical company. We don't call us deep tech for nothing, right? And the idea that there are people within that company who can diligence what we're doing and get in and work with our team and truly understand what we're doing. So it feels to me as if somehow or other, there's a lot of expertise that exists within these large companies. There isn't maybe as much innovation, but there are resources there that we can tie into. And that's the kind of connection point that I think is really helpful, actually on both sides.
Yeah, and it's interesting because you're surveying executives or CIOs or whatever the sample was, and they're saying that they think a third of these deep tech solutions are coming essentially from their peers.
Yeah.
So other large enterprises, which where I'm sitting,
Right.
I'm like, no way.
Yeah.
I'm surprised it's a third.
Yeah.
Right.
Right.
And I wonder if it's skewed based on industry. Like we work in mining and ag. I'd be shocked if they thought, a third came from startups. They might think 80% comes from their own industry.
Right.
And the rest is just lab experiments happening here and there. Do you think there's like an industry kind of skew here?
There
based on
may,
that?
yeah, there may be. I think that, when you're working with AI, for example, I suspect that's not the case. In drone technology, it may be the case where they see, other companies, big defense companies or whatever working on things. It's possible. But I think in like areas like where we're in, I mean, it's clearly not the case.
Yeah, I feel like if that survey were to be done and sort of exposed based on the industry, I wonder if
Right.
you'd really shine a light on certain people. Like, this one industry is like, there's 2/3 of the technology is coming from outside of my walls. And others is like, nothing's coming from outside of my walls.
Yeah.
It's all in here and we're good.
Yeah.
It'd be like an interesting like shining of light on what's going on there, I think. Right.
I agree. And one of the other things is where they're relying on information from to support their thinking about making these kinds of investments. Because, I would have thought that, again, maybe some of it would come from internal research, but where we're seeing is consulting companies are, BCG and Bain and McKinsey and, et cetera, are all, Gartner, whatever, are all becoming much more important because these people, people within these large corporations don't have the resources to be able to figure out markets, technology, et cetera. So I think it's a tacit kind of acceptance of the fact that they need to look outside of the organization, not only for solutions, but also for support about market sizes and competition and who they should be working with.
So one of the fundamental things that I was trying to pull from the statistics you had in there was what is the view on deep tech in terms of an investable business? And so there's the burning need,
Right.
There's the fear of competition, but if in a Seek or another company that's investing in a high capex and this deep tech technology, what makes them sort of an investable business to back for you?
Look, one of the really exciting parts about doing deep tech work and investing is that you're building new platforms, you're building whole ecosystems. And because of that, it creates an opportunity not only for the company, but everything that surrounds that company. So it's funny, in quantum computing, people think about, in venture capital, people think about, winner take all and a moat and everything. And they'll say, oh, what's the winner take all quantum computing company? And I said, no, you got it wrong. Quantum computing is an ecosystem, the way classical computing is an ecosystem. And so you're going to invest in chip companies and memory companies and networking companies and application companies and operating system companies, et cetera, et cetera. And it's going to go down the line, and you're going to need all of those in the quantum ecosystem. So when you're making an investment, you're investing actually in not just that company, but the opportunity to invest in the whole ecosystem of quantum computing. And I think that opportunity is incredibly rare. And so in some respects, I think we're doing the venture capital industry like a tremendous service, because the venture business has really narrowed, I think, to investing in my view, into like novel business models. And occasionally somebody will come up with, I don't know, a scooter or something like that. But when you can invent something like, imagine for a moment it's 1946 and somebody says, oh, there's this thing that's going to be called digital computing. You have an opportunity to invest in it. Think about all the opportunities that have been created for making investments in so many ways where you can win. And I think that's what we're doing, not just at Seek and in quantum computing, but across all of these areas.
Yeah, right. And then first of all, I'm going to use that line next time. I'm doing you a service. You should invest in us. That's a good one, John. Everyone should copy that one. That's one of the things I noticed too, like in the innovation studios we run at New Lab, we really focus on the validation aspect of this, because what we've noticed is that when we look at the startups we work with, almost always deep tech startups, high valuations, lots of capital in, bunch of engineers, not a lot of BD, what's their traction, and so on. And what makes an investor sometimes flip their view on that company is some level of significant industry validation. And that doesn't mean the product's been purchased, but the fact that it's been deployed on site, this is the data that's been generated, this is the feedback we're getting from these major industry partners, I think does a few things we just talked about. It shows that the startup is focused on a problem. It shows that the industry is paying attention. And all of a sudden, private capital is interested in this, whereas before it was just a science project. And I can point to examples across so many different industries where that's true.
Yeah.
And so to me, it just comes right back to this idea of like executives, industry, sort of believing that this work is happening outside their walls and understanding what that roadmap should be for their problem sets and challenges they have, and then using that to pull in the private capital as a service to the VCs.
Yeah, there you go.
Right,
but
like,
it also points out something else, which is that they're successful in being able to articulate the value that they're creating, and they've been able to sell that concept to someone who, again, is more or less pretty conservative about it, because again, they're sticking their heads out before to do this.
Right.
It's a tricky decision to make when you're at a company. I mean, it's a little bit different when you're at a portfolio, you're in a venture capital fund where you're making, a whole bunch of bets. If you're the person that's basically making that commitment based on, all that you've seen and heard, say at New Lab and in a particular company, you have to have high conviction. And I think that's a, kind of a wonderful position to be in.
Yeah. So what else, anything surprised you in the report? Like when you saw the data for the first time?
Yeah, so I think one of the things that it's funny, I was thinking about that the reliance on finding companies with IP and where they've set up a lot of, physical infrastructure to be able to support the technology. Because I think what the first one is saying is, hey, if we get this right, is this protectable, right? And B is, how can we reduce the ticket in? And if it takes a lot of money and, like we have a chip foundry, for example, among other things, and, it's hundreds of millions of dollars to do that, we want to make sure that we're not having to spend all that money. So if I can get somebody else to have, sort of built that infrastructure for me, I'm happy to leverage it. But so I think that was that.
Yeah. So, John, I'm not surprised that you and I have gone over time again.
Right.
So,
Right.
I mean, final comment from me is I do think that, just as the ethos at New Lab, it does take sort of this community of stakeholders that are all together to
Mm.
solve a major problem. It's industry, it's major large corporations, it's government, it's R&D at the startup and academic level. And I think quantum is becoming a great example of that. And I think what your report showed is that it does take that type of sort of shared interest and coalition building to really solve really big challenges with deep tech. And that report was very eye-opening for me. So I really appreciate you guys doing that.
Well, thanks. And again, thanks for having this conversation. I hope it's been helpful for, the New Lab community and the greater community, because I think that was really our goal.
We had a couple good audience questions coming through online that I thought I'd share. I'm over here, John.
Oh, there you are.
Yeah.
It's like the Wizard of Oz.
And I picked my favorite one, and you're going to know why when I ask it. But they latched onto your concept of developing simple problem-based solutions first with difficult technology and advanced tech. And the question was, if you look at the self-driving car world in the US, there's two major players. Waymo testing in Chandler, Arizona, a simple suburban environment to begin with, rolling up to the more difficult, dense urban environments. Compare that to Cruise from GM and Y Combinator, starting in downtown San Francisco, the most difficult environment to test and develop the technology. Is the simple first solution always the best?
Should I go first?
Go for it, man.
So my opinion there, and I'm talking to Sean, who of course
Yeah, right.
should be the one to answer this question, right?
Who's asking this question? I
So-
mean, who's reading the question?
So Waymo and Cruise definitely different approaches to getting to solving the grand challenge of what autonomous driving is. To me, what I'm seeing in the near term is how do you use AV to solve near-term challenges of society? For example, closed circuits within the Brooklyn Navy Yard, like Optimus Ride. Or how do I use the AVs to solve last mile delivery for pharmacies for the elderly that live in communities, right? There's fixed routes that we can use, for example, where we can serve the communities today while we're working towards the greater goal, which is obviously what Waymo and Cruise are looking at. So to me, like, yes, they're solving a big problem, but there are others that are looking at more of the near term right now.
Yeah, and I'm just concerned that, you can take any grand challenge and say, yeah, it's worth it for me to spend, the rest of my life trying to realize that vision and never get there. And creating, taking first steps that are actually achievable, I think gives you something to build on and gives other people something to build on.
Yeah, I mean, for you, like quantum computing is also a little bit about trust, and so is AV, right? So, so the comfort level of by the time Waymo solves this problem, people will know what that means because they've probably sat in a shuttle that's taken them to a ferry, or they received a last mile delivery good through some sort of autonomous system. So it won't be such a foreign concept to sit in a vehicle like that from door to door.
Right, which,
quantum, right?
Yeah, exactly. And I think to the extent that we're able to model something that's very simple, and it just shows and provides confidence, by the way, that we're going to be able to do something that's incrementally more complex. And again, I just think building on achievable milestones is really, really important when we're trying to do something that's really big. And I think all of these things that we had on our list are, I mean, these are all, kind of world-changing technology platforms.
I don't know if there's any audience questions, or I have more online, but okay, I'll go to the next one on the online section, which is taking you back to quantum computing. Quantum computing as a technology has the ability to be used for great good and for great harm. Government involvement will be key. How should government be involved in collaborating with the startups, academic institutions, and corporations that you referenced that quantum is being developed in?
It's a super interesting question because Alex, who's going to be moderating the panel, he and I were just talking about this just a moment ago, which is there's a group that's been formed with the Hudson Institute to talk about the ethical implications of quantum computing, thinking about kind of what we didn't get right with respect to AI, for example. And I think we are at a nascent point and at a good point to be able to have those kinds of conversations. I'm super interested in that topic because I think that we do need to answer that. We do need to identify how this can go wrong, because I think any technology can go wrong. The question as to whether governments should be involved, I think is a wholly different one. I don't know. I can't actually identify what a regulatory environment might look like other than what people talk about now, for example, which is around export control where they don't want to make sure that these kinds of technologies don't get in the hands of people who could use them for ill, and particularly against our country. But aside from that, I don't yet have a clear enough view as to what government should do about quantum computing. I mean, let's first make it work, but I do think that this work to begin to ask questions around what are the implications of these technologies. Quantum computing is just one of them. I think is really, really important. I think in the AI case, that question is only now being asked.
Yeah, fair enough. I think eventually though, government will have to solve certain aspects, right? So for me, investment in R&D in the United States is key.
For sure.
You talk about the race. I think pouring in we know quantum is going to solve some of the world's greatest challenges. We know it's something we need to have in the US. Number two, I don't know what you think about the word infrastructure when it comes to quantum computing, but very similar to how the government now today is setting up for the energy transition in the future. I wonder if some of that investment should go into this. What does everyday life look like if quantum computing is ubiquitous? What do we need to do today for that? And then finally, the third thing which you talked about is ethics and policy. I don't know when,
right,
but certainly down the road that needs to be solved.
Yeah, but I think it's, I just think it's compelling to ask the question now, before people, build out these systems, before they start to do things that we never thought about. And I just think it's useful to have those conversations now.
Amazing. Oh, unless there's any audience questions, I'm way over time and Cody's telling me to wrap it up. Amazing. Well, join me in thanking Satish and John for this helpful discussion.
Thanks.
We're just going to set the stage up for the second session, which is a small panel discussion with Alex that John just mentioned. While we do that, we had actually a representative from an international government here this week. And when I asked him the question of what are the technologies you think are the most important to track, support, and develop in regards to the future of your country, should I be on stage? Whoop. He responded so quickly and he said two things. And he said quantum and fusion. And I've never heard anyone answer that question. I ask a lot of people that come here. And I said, explain that to me. And he said, fusion will give one country unlimited energy. As a human being, they'll be able to do anything on a daily basis. And quantum will give them unlimited brain power and capacity to think and process information. And that was the end of the answer. And I thought, that's the best answer I've ever had. And so with that in mind, we'd like to welcome Alex to the stage to introduce his panel today. Alex is the CEO of Quantum Daily, a keen tracker and contributor to the advanced technology field. And we're thrilled to welcome him here to introduce his panel. Thank you.
Thank you so much, Sean. Well, thank you all for joining. It's been an absolute pleasure to spend time today at New Labs. I stepped in here with very little knowledge of the amazing work that's been going on here. And I was struck by seeing, electrified motorcycles. I've seen, rocket industry. I've seen people doing some incredible stuff. So it's been brilliant to be here. So my name is Alex Challens. I'm the CEO of the Quantum Daily and Deep Tech Insider. I set this up after a career in the private equity industry. So I'm really excited to see both sides of the story today. I'm joined by a set of people whose CVs, frankly, are going to take up the entire panel. So we're just going to keep it short. So we've got John Levy, who's the CEO of Seek. We've got Zhang Ma, who's a founder of a SPAC focused on deep tech. And we've got Daniel Franco, principal of M Ventures. So thank you all for being here today. So look, I want to start off with actually a personal question for you all. What is it that got you interested in deep tech? And I'm going to start with Daniel to understand, why you moved from the industry side into the investment space in that front.
It's a good question. I think for me, it's probably scientific curiosity, I would say. And actually, I have a funny story. Last time I was here, there was an IBM quantum event. Oh, yeah. And I don't know if anyone from the audience was here as well, but in this specific room, there was a DJ playing a set where he was, I think, sampling some noise from a quantum computer and turning the microwave signals into audible sounds. And he's playing like a 30-minute set. I thought it was amazing. And I think that's kind of the stuff why I like being in deep tech, to like go to these events, see these kind of things. And I think there's both the scientific curiosity to it, and then also it's just fun. It's creative, right? Deep tech has to be creative, I think, by definition. And then looking at it from a VC lens, I think is it kind of brings the necessity with it to see, can we actually make something happen that has an impact on society?
Absolutely. And John, you came from the investment world as well, and you decided to set up a firm in the deep tech space. So why was that?
You know, it's funny. I think to me, I'm always interested in the hardest problems that have the most impact. And it's almost like it's almost a definition of what deep tech is. And I was the chair of a company that spun out of IBM that was doing superconductive electronics. And it struck me that we had an opportunity to apply this to quantum computing. And I thought, quantum computing, I mean, this is like the operating system of the natural world. We need to be able to harness that, and that's consequential. And you know, I don't have so many, none of us have so many opportunities to do things that are that consequential. And for me, it just seemed like a privilege to do this, that this was an opportunity and a privilege and a responsibility almost, and one that I just knew if we get right is just massively important. And so that excites me, but I'm kind of a nerd that way.
And yourself, you set up a SPAC to go after investment in the space. What drove you to do that?
Was a great question. So I have a technical background. I worked in Bell Labs before, and then today I walk into this building and I think, wow, this is almost similar to the Homedale building I was in, you know, in terms of the architecture. It's just so amazing. So I've been investing, I was an entrepreneur and I was an engineer, and I've been in the venture capital for the last 16 years. And I see many great deep tech companies, and they do need capital to scale. And one way to really access to the capital is, you know, going through the public market and be able to build credibility and be able to establish themselves faster, which, you know, it was, I would say a couple of years ago, it was a lot more challenging for deep tech company to raise money. And so that's part of the reason I said this SPAC could be very interesting, and I'm very excited.
And it seems like there's quite a few challenges, isn't there, to raising capital when you have to explain your company, you have to, you know, explain that you need way more money than the enterprise software company next door. How do you think about that as investors first? Maybe to you first, Daniel.
Yeah, I think raising money is always the tricky thing, right? I mean, that's if you see the first thing, if you get up in the morning, is check, do all my companies have money, right? Can they operate? At least that's when I get sleepless nights, when I think, you know, timelines are running short. And I think I actually want to pick up on something that John had discussed, kind of this, what's a good way you can demonstrate, right, to investors. It's not only to corporates, but you have to keep investors happy, right? And I think for me, what I always look for, especially in deep tech, is not necessarily the proof of principle. It doesn't need to be commercially meaningful, right, or technologically super meaningful, but it needs to have this vision of scalability, right? So if I see a set of data, I want to make sure that from that data, I can interpolate that things are going well. And I think that maybe going back to the question on the two different AVs, right? I think the initial problem doesn't have to be meaningful, but it has to show that the technology can scale, I think. And I think with scalability, with kind of this big picture vision, also then comes the ability to get money into companies.
And how do you go about that? One of the stats in the report that we saw earlier was fascinating, which is something like 80% of people have fears or anxieties around investing in deep tech. How do you get over that, John, when you're speaking to investors? How do you educate them?
Yeah, again, I think one of the things that's interesting about going to large corporations versus say financial investors is financial investors, and I've had lots of meetings where I present and they say, this is great, this is great. We don't have anybody to diligence this. We have no way of understanding it. And thinking about what Sean was saying about like fusion. I mean, think about how many venture capital funds have people on their staff, or maybe even know many people who could actually diligence a fusion-based company. But the fact is that if you go to large companies that are energy companies, there's a chance that somebody does have that expertise. And so dealing with identifying potential users of the technology suggests to me that there may be people within those companies who actually have this real knowledge, and you can tap into that and you can leverage that. So it's fine for me to be able to tell a good story about our technology, but at the end of the day, somebody has to be able to validate it. And at the point I think that we're in, more venture capital funds don't have that capacity, and large companies do.
I think I can quickly tag on to this, because I think for example, when we started looking into quantum, I think 4 years ago roughly, we knew we wanted to make an investment because we were convinced of the kind of breakthrough potential, but we had no idea. We were completely blank page. We didn't know we didn't know superconductors really. We didn't know trapped ions. We didn't know anything really. But we're a corporate fund, right? So M Ventures is the corporate fund of Merck KGaA, Darmstadt, Germany. And there's, I think, 70,000 people working for the company, and it's across healthcare, life sciences, electronics. So there's people that understand quantum, at least somewhere in the business. And for us, I think what we did, we started this task force with, I think initially maybe 10 people, and now we're up to almost 100 people in quantum, to really look into all the companies, look into all the technologies, really trying to understand, and then over maybe a year, build kind of an investment thesis. What are the bottlenecks? What are the companies addressing the bottlenecks? What are the companies interesting to work with from a corporate perspective? And then also from a venture side, what are the companies that can actually be good investment target, because they're not always the same thing. Sometimes they are, don't have to be, I guess. But it takes time, right? Just kind of this process of figuring out something so complex as quantum. But we do it for all kinds of other stuff. We do it for augmented reality. We're actually doing a deal in Fusion right now. I don't know if I can talk about this.
Yeah.
So yeah, it's challenging.
So we actually made an investment in Fusion. This is my previous venture capital life. As John said, we in-house, we have no expertise to due diligence a Fusion company. We spent a year. We hired a lot of industry expert, and really producing a lot of a really serious study and report. In the venture capital space, sometimes you have a portfolio, right? You can have one or two companies that are totally swing for the fences, right? Maybe it can fail. It's okay.
Right.
So those kind of deals we do, and maybe we do. Some of the companies are more mature, later stage. They will generate return for our investors. So I think sort of deep tech traditionally fall into that kind of bucket. Okay, let's try one or two of those totally crazy ideas. Maybe we fail, but it's okay. But we still hire like outside consultant. It took a lot of effort and a lot of debate internally, like who's for the deal, who's against the deal. You need a lot of convincing and internally. And hopefully our Fusion deal will pay off one day. It's still not exit yet, so I don't know yet, right? So, and also I think I think the corporate seems to be really important for like big ideas. And I think if you are going to a traditional investor, you say, look, I have 3 use cases. One with Merck, one with, let's just say, with another biotech firm, maybe another with a hedge fund. They're doing, other quantum computing algorithm. And so you have 3 different use cases, and they're, really powerful. That could be a really good case for, building a, sort of the, investment thesis as well, right? I think but most time, deep tech really address, is the market big enough or not? That's the number one question, right? If you're solving a problem, maybe very hard, but addressable market is probably also very small, probably not worth pursuing, right? But John said, the work he's doing is to make huge impact on the entire quantum computing field, because he's not competing like you're going this way or that way. He's really building an infrastructure layer to support, right? I think that's really critical, right?
Of course.
So that's kind of how me as a VC looking at investing, we're really looking at, Daniel said, to be able to scale, you had to be able to address a really multiple market and solving very, very large problem. Yeah.
Yeah, it's interesting. When we were thinking about spinning out, we were thinking very much about Do we want to be a vertical company, or do we want to be kind of more of a platform? And I think part of the issue for us was that if we were vertical, we could get that wrong. But if we were a platform, we would have sort of multiple shots on goal to be able to try, kind of the work that we're doing and see what is achievable in an investable time period. And it gave us that kind of flexibility. So our investor group actually reflects that, where we have enough kind of corporate support aligned with very specific use cases, so we can see how that plays out.
You talked about finding specific use cases. I'm really curious around. I was speaking to Frederick earlier around trigger points and getting religion on a certain sector. And I thought religion was an interesting term to use, where almost suspending belief that the stuff that everyone here is working incredibly hard on is it actually possible? Personally for you, for everyone on this panel, really, what was the point where you thought, you know what? I'm not mad. This is actually going to work. This is something I want to dedicate my time to. This is where I want to focus as an investor. How did you think about that?
Well, I think yes, there's many factors, I guess, combined. Number one is for me, it's always about people who are actually working on the project. Do I have enough conviction they're the right people? Do they have the right background? And the dedication. It's going to be very difficult, right? It's not going to be as simple. So I think, sometimes that chemistry, that inspiration, I thought it was, sometimes the trigger point. But you can meet like 10 different entrepreneurs in different ways of solving problems. But eventually, I think that comes down to, that kind of the combination factor, I would say. The people, the dedication, maybe the environment. Like, if you are surrounded by, let's say you are in the New Labs environment, you are surrounded by, very talented group of people, you might be able to walk across the hall, having some other ideas coming to you as well, right? So being like in a very isolated, I would say, environment sometimes is very hard.
Yeah, it's funny, by the way, that you worked at Bell Labs, because Bell Labs had that. I worked at a think tank in Silicon Valley called Interval Research that Paul Allen funded, and it too had that really kind of cross-disciplinary kind of approach to problem solving. So people would, people who had backgrounds in genetics and ethnographic filmmaking would come to our brainstorming sessions when we were working on some new applications in the field of computer vision and things like that. So I mean, having that, but I think going back to it, developing the conviction around something, I think there are two things. One is, in our case, we spun out of a company that I had chaired where we had actually built whole superconductive electronic product. So we had confidence that we can do that on the one hand. And on the other hand, you look around, and I think it's probably true in a lot of these fields, there are other companies that are doing what we're trying to do. They're doing it differently. They have different goals and different technologies, but they are making some success in quantum computing. And I think the same is true. You read the newspapers about fusion, around AV, certainly around AI, around robotics. You begin to see that there's an ecosystem of other companies that are showing some level of success. And I think that's another, kind of an external view.
The ecosystem point is quite relevant, I think, here. Obviously you've got spaces like New Labs, and then we were talking about the impact of government on this space as well. Do we think that deep tech has some unique characteristics compared to the classic tech industry, which we need to consider from an ecosystem perspective?
Yeah, I would say absolutely. I think for me, the biggest point is that corporate VCs actually play a more important role in deep tech. And we, for example, rarely do deals by ourselves. We always do it in syndicates. And I would say the best syndicates is usually where you have a financial VC with deep pockets, someone who can write much larger checks than we do. And we can write reasonable checks. But once you get to this 20, 30, 50 million checks, then that's where we tap out essentially. But ideally, you want to have a good set of corporates around, and corporate funds that do actual venture capital, not corporate business development. And I think for companies, that can be extremely helpful if you set up in this way, because that's, I guess, symbiosis between the financials kind of looking to the corporates to bring that validation is important. And then obviously the corporates looking for financial to bring the money, and obviously some management skills, market access skills, I think is especially in deep tech more important than in regular tech investment, I would say.
Mhm.
You know, we live in a country where industrial policy from the government side is not a very popular thing. You know, people always say, you don't want to pick winners, right? And there'll always be an example of, Solyndra as, like as an example for that. But the fact is that we do make investments in technical infrastructure on big things, the internet, for example, and all kinds of material science and robotics and space and all of these things, for which we've had, tremendous returns. And I think that more and more, at least in this country, we begin to think that our competitors have very active industrial policy. The Chinese government, for example, announced that they're putting $10 billion into building a quantum computing center. Well, that's not a trivial number, and they're getting really great results. European countries are doing the same thing, and I think we in this country are rethinking the role of government, and particularly around deep tech, from an economic security perspective, and even from a defense kind of security perspective. Right now, for example, we're in the semiconductor world, we're having a shortage of chips, and we don't have a reliable domestic supply of semiconductors and superconductors. And so you really kind of have to think about, well, what are the conditions that created that? Some of them are political, some of them are policy, but the fact is we don't have it. And when we don't have it, it means that we can't produce more cars and trucks, and that has downstream effects which are, tremendously damaging to our economy. So it's important, I think, to say there is a role for government in doing this, but I don't think that it should dominate. And I think the idea of having this combination, and I think, Sean was mentioning it and Satish was mentioning it, this kind of combination of private companies, startups, academia, and government, I think is a really, really good one.
Alex, we do have an audience question. I'm over here, sorry.
Hey.
Got a couple audience questions whenever you're ready. The first one was, what is your suggestions from a personal perspective for investors looking to develop their own personal portfolios in deep tech? Are there ways to access many of the deal flow you all review on a daily basis?
That's a good question. Yeah, you want to answer?
Well, John, you're like doing a SPAC, right? I mean, there you go.
So yeah, one way to access public market, but this is not for everybody, right? But there's a lot of deep tech companies going out. The quantum computing company. You see a few battery companies and also EV companies, right? And most of them are, I would say, still a little bit further out in terms of revenue, but but if you study hard enough, you might feel like pick one or two companies. So that's one way. There are also a lot of angel network. You might be able to participate, I think, locally. This is based on where you're located. So that's kind of my advice, yeah.
Yeah, I would just make a lot of friends. I think that's probably the most important. Try to call up every VC that invests in the areas you're interested in. And I think that's, at least for when we started trying to look into something very new where we haven't made a single investment, we really try to see who are the people who actually know about this, and then try to chat up those people. And then slowly, build credibility in those spaces by doing good work on the investments you've made.
Yeah, I don't know if anybody's actually created an ETF or a mutual fund or something like that that's buying.
There's a quantum ETF, I think. Yeah.
Great.
I didn't know that.
We're on it, yeah.
Yeah. Yeah. I mean, I just think that trying to get some form of diversification is probably a very wise idea in this field. Right. Because, it's interesting. I think just, again, focusing back on the quantum space, I think the notion is you want to invest in quantum computing. You may not want to invest in a particular quantum computing company. So if you're an institutional investor, if you're like a Wellington or a Fidelity or T. Rowe or somebody like that, you want to make sure that you're invested in the space. And to do that, you need to have maybe 5, 6, 7 different investments in quantum computing companies, because you may be right about, you may be wrong actually about 4 of them, but you're going to be spectacularly right about 2 of them. And it'll more than pay off for the others.
Yeah, just building on that question, I'm very curious of why you took the SPAC route to invest in deep tech. Was there particular reasons for the capital structure or other reasons that you chose to do that route?
Very good question. I think, you know, a SPAC is a new, I would say, new tool for investing, you know, in companies. And I think it's quite interesting for, I mean, for my personal view, as Daniel said, you know, when I was doing venture, I also worry a lot of times about my company running out of capital. And with VCs, money are really designed to fund, I would say, the early part of the company's journey. But when the company really able to scale, that's kind of when venture capital money become very expensive. A huge dilution to the company, to the funders. That's kind of where the, you know, the SPAC or even direct public, it become much more, I guess, favorable to the management team, to the funders, because they are able to access the public market at a more attractive valuation, I would say. And I think there's appetite now because you see the success of the, you know, young companies want the public and be able to, I would say, you know, beat off the competition because you can now, because now you have more capital, right? You can grow much faster. You can do acquisition, you know, you become more creative. So you can be dominant, right? So that's kind of the way why you want to go public quickly. Of course, there's a lot more work need to be done as well. So it's not that easy. So that's my view.
Yeah, I got to say, I think it's going to be a daunting position to be, you know, a CEO of a deep tech company that's made the promise of generating $500 million of revenue in the next 4 years when you're not generating anything. And, you know, maybe you miss your earnings. So I think there's a reason why companies stay private for a long time. On the other hand, the idea of creating, you know, this vast amount of capital that goes into the company, you know, helps with recruiting. It helps with CapEx and expansion. It helps with runway. It helps potentially with M&A. And so I think there's some, you know, obviously really strong points for doing this.
Right. So it's definitely not for everybody.
That's for sure.
Isn't it? We were joking about some of the revenue projections earlier, and I thought it was go and have a look at some of the recent ones. But that part of it is, you know, it's back to the point of suspension of belief. You know, there will be companies that massively outperform that. But it does bring a question around hype in this industry. Around, you know, quantum is one that's been called out a lot. How do you, both as investors and founders, deal with hype? How do you use it to your advantage, but also moderate it? What are the key considerations?
Yeah, hype can certainly be a useful tool, right? Especially when you already invested and your companies are raising, right? That's awesome. I mean, it's often, on the other side, when you're making a first investment, it's extremely challenging, right? Because you're getting maybe pressured, right? Or maybe you're pressuring yourself. It's like, hey, this is a hot topic. We don't have anything in this portfolio. It fits. There's a lot of companies at the right stage. We should make something. So it can be quite challenging, especially I think for your internal biases, right? To get past those. This is actually really something where we should make an investment based on, do we think it actually works? But I think, especially for quantum on the public markets, I don't actually see it too challenging. I would say, like these early stage companies going public, because essentially in biotech, it's been happening for years, right? So, and people are just okay with, you know, biotech companies go public before they have drugs in the markets. You know, there's different stages in the drug approval process, and companies fail like regularly, right? And then they go to almost zero because their prime candidate failed in a phase 2 or phase 3 clinical trials. But on a portfolio level, it works, right? Because the biotech ETF is performing extremely well, right? Because exactly what you said, right? On a portfolio level, the winners really outperform everything. And so you have to have a balanced approach. And I think it's always tough when, for example, in quantum, maybe now the first 2 companies go public, right? Because then you have this massive risk located in 2 assets essentially, right? But if you have a more balanced approach, I don't think it's the hype there on that end is that bad, honestly.
One of the challenges I see across multiple markets is this: as this flood of funding comes in, it effectively takes away resources from institutions, national labs, for example. How do we manage that kind of that challenge of keeping people, focused on fundamental research, but also moving that into the commercial realm?
Yeah, I mean, there's a lot of work being done right now in terms of trying to, there's something called USICA, the US Innovation and Competition Act, and there's an identification of something like 10 or 12 different core technologies. And the idea, quantum being one of them, but a bunch of others, mostly the list, pretty much the list that we showed in our report. I mean, it's very much aligned with that. And I think part of what that bill is trying to do, and it's a $250 billion bill, so it's a big, a bit of policy, is to make sure that money goes to the national labs, it goes to academia, it goes to small companies, and to really try to balance that out. And I think that's a challenge. I mean, that's really a challenge because you've got federal bureaucracy that wants to be fed. You've got, sorry, you have the national labs where, they're used to taking money in. You have the National Science Foundation where they're used to sending money out. And then you have academia. And so I think creating partnerships around all of that and doing it in conjunction with small companies, I think is a really winning formula if this can be pulled off. But I think it's very, very challenging. And I think it's one of the reasons why, again, we as a country haven't embraced industrial policy as much, because it requires this kind of, integration and cooperation. But I think there's a chance.
Just one thing that I think the important thing, especially for public funding in academic research, is also not just magnitude, it's also kind of the level or which it's paid out, right? So I think strong funding is good, but I think medium and sustained funding is almost better oftentimes, right? Because these academic labs, they run on 5-year cycles, and a PhD leaves, and if there's no more funding, the projects get kind of X, right? So I think the having the more certainty on the academic side in terms of funding commitment over time, so for all these deep tech things and biotech and whatnot, I think is super important. Probably more important than I think just the amount of money that goes into a specific academic field.
Yeah, I agree. I think that's super important, right? Yeah. So keep the pipeline going, right? You can't have everyone going to startups and nobody doing like fundamental research, right? It's super important. Yeah.
And how are you finding it, as you operate in the deep tech space, how are you finding the right people? When the industries move so fast and requirements change so quickly, what is that like?
That's a good question. Maybe John should answer that.
Let's just say it's a recruiting nightmare. It's funny because we think that we can't find jobs for so many people, or so many unfilled jobs, I should say. But if we think about the number of people who exist at the intersection of theoretical physics, computer science, and electrical engineering, let's just say there aren't a lot of them. And then you're competing against Google, IBM, Microsoft, Amazon, Intel, et cetera, and then a group of other well-funded startups. So recruiting is really, really a challenge. But one of the things that I think where we've had some success is in the fact that we actually have a mission, that we want to be impactful in what we do, that people see that there's a purpose for our technology. It's not technology for technology's sake, and that the architectural approach that we're taking is novel and ultimately scalable, and is the way that quantum computing has to grow. It has to go from an academic approach to a more systematic kind of enterprise computing approach, which is based on chips. And we build those chips, and we design them, we build them, we test them, we integrate them into solutions. And so people get excited about that idea. And that's really our competitive advantage when it comes to identifying and attracting, the best people in our field.
We got another audience question for you guys, Alex. Sorry to interrupt you.
That's all right. I keep trying to find you.
Yeah, I'm back here. It said, you all discussed the issue of due diligence around investing. Is there a scarcity of intellectual capacity and capital in deep tech? Are immigration regulations hurting identifying and retaining intellectual capital?
Yes. So, I mean, we could talk about immigration, and we can probably be here for another 60 minutes. I immigrant myself, it's crazy. And every one of our company has challenges with hiring, and a lot of it is immigration, and especially in deep tech, and other companies are catching up. Like in Taiwan, I think average salary for chip design has doubled in the last 1.5 years, doubled. It's absolutely crazy, right? And it's almost at US level now. So, right, why not stay in Taiwan, right? Why? To me, it's crazy. So there's definitely scarcity on it on the hiring side in all of our portfolio companies.
Yeah, I think on the information side as well, there's so much now that you need to collect in terms of data and information. And the additional thing that in deep tech, which makes it really hard, is you've got this whole learning curve before you even start to comprehend the commercial implications. So for example, to even start understanding quantum computing, you probably need to spend 10 minutes watching the perfunctory video explaining how a qubit works. And the same thing with space, is understanding the materials that go into a rocket. And that clearly creates a barrier to entry versus creating the next enterprise software business or creating the next consumer startup. I mean, I'd be curious to hear the panel's view on how you go about it as investors, how you think about a consumer investment versus a deep tech investment. What's the playbook?
Yeah, maybe I can go very quickly. So interestingly, quantum computing is new. It has been around for 40 years, right?
Yeah,
At least
like
40 years. And when I was at Bell Labs, we have quantum computing workshop every Friday. Yes. Every Friday morning, I was there listening, discussion. So it was like, it's just so many mathematicians, physicists are working there. Some of them retired, become professors in other universities. For example, I was looking at a quantum computing company a couple of weeks ago, and I was able to access to some of the old colleagues from Bell Labs, and they are still, even they're retired, still very interested. So I think you're trying to really finding the domain expert, because quantum computing has a very different approach, right? And also I think most importantly, you need to find people who actually make things to know if this is practically, can you not just theoretically work, can you actually practically make it? And if you mentioned about ecosystem, can you manufacturing this, right? It's chips and using existing sort of the in-fab or foundry, so you have to totally create a new foundry. So there's a lot of questions need to be answered there, and I think so that's kind of things on my mind when I start doing due diligence. Like practical people used to run a fab or work in the Intel and work in somewhere, and some people work in Google today, and I think the practical understanding about the milestones, like with this much capital, what are kind of milestones I can achieve? If that milestones very impactful, then this company will be able to do next. So you can't have you won't try and divide all this difficult task into different milestones. Yeah, that's my answer.
We had another one from the audience too, which was regarding return on investment in your world. They said the deep tech world has typically been known for long timelines for liquidity and return on investment. Has that changed, or do you still go into investments expecting a decade plus timeline to liquidity?
What do you think?
I think it has changed. I think, especially with the specs around and a lot more deep tech areas open for public markets. I think it has changed. And I think John's comment on the portfolio is extremely right. So you have a few companies where you say, okay, this is definitely going to be one that's 10 years, and we're okay with this, right? Not every one of our companies is like this. So I think if you look at it like this, I think there's definitely good deals you can make with, I think, reasonable time windows where you can get to liquidity within 3 years or so. And M&A has been hotter than ever, right? I don't know all the numbers, but the markets we're in, I think it's record high pretty much, if not this year, the last 2-3 years in across all these deep tech verticals.
It's an interesting question to think about financial returns from an investment. So from a financial investor or sorry, a strategic investor, what a financial return looks like versus what a practical return from a product perspective is for an individual company where it's contributing to the bottom line.
Very different, yeah.
Those are two really different ideas. And so when we did our report, we were asking this question around what is an expected time period that you would think. And I forget what the number was. It was like, but it was in the mid to high 50s of companies that felt that they could do that within 1 to 5 years. And I always wondered about that, whether, I mean, it's one thing, I think, to get a financial return in that time. I'm not sure from a product perspective that you can develop the technology, get it out of R&D, get it into a product group, get it, sort of built and marketed, through a company in that time period. I'm not sure that's realistic, but I think from a financial perspective, it may well be.
Yeah, and it's certainly, you've got to demarcate between getting cash out as an investment versus your up valuation for your next round.
Yeah.
And what we're seeing at the moment is, incredibly rapid Series A, B, C, D rounds. And so if you're mark to market your portfolio, you can do incredibly well in the deep tech space, particularly, actually. And I don't think the time horizons are any different on that. But exactly to John's point, it's a very different question around where you start making profit.
Yeah, and I think part of the issue with deep tech is that, in almost every case, the ultimate market that you're dealing with is massive. It's just huge. And whether it's AI or whether it's robotics or whether it's additive manufacturing or whatever it is, these are huge markets. And that's what you're investing in. And so investors get that. They understand that. And they understand that if you're successful, it's going to be an outsized return. And that's really, and they can see that, I think, before necessarily, for example, fusion comes online.
Yeah, correct.
The next one pits geographies against each other, so I hope this is okay. But this question stated, there are regions that are starting to focus from a state government perspective on specific technologies. California for hydrogen transportation and Louisiana for hydrogen production as an example. Do you look to specific geographies when trying to invest in specific fields, or do you find these investment opportunities globally?
It's a very, very good question.
We invest globally. So we have an office our main office is actually in Amsterdam, in the Netherlands. We have a German office, Israel office, US office. So we tend to look pretty globally, but of course there's definitely hotbeds, right? So like Boston is hot for biotech, right? So Austin has a specific scene, right? So New York offices focus on maybe more fintech. So it's definitely, I would say, local focus, but I mean, there's good companies everywhere, right? And I think also a lot of areas are vastly overlooked, like the Midwest, for example, with really good schools, good engineering schools. And yeah, I think it's more about where you spend your time looking rather than, I think, looking in a specific geography.
Right. I think actually for deep tech, it's much more distributed around globe, right? I think for the internet, maybe there's a lot more Silicon Valley and semiconductors or Silicon Valley seems concentrated. So I think, I spend a lot of time in the energy efficiency, energy world. Definitely very distributed. You see Houston, you see Florida, Michigan. So I think the deep tech, it definitely has hubs, right? It's National Science Foundation funded, university. There's a couple of universities focusing on quantum, right? And there's a couple of universities focused on laser, which is very important for quantum, right? It's this whole ecosystem of quantum it's not just computing piece, right? You need other pieces to support. So I think there's definitely kind of certain kind of talent for certain kind of, technology.
Yeah, I think part of it also is, where are the people who have these skills? And we decided to keep our headquarters in New York State, but we're building out a team in the UK and we're building out a team in the EU because, and maybe we would do it in Asia as well, because you have to find talent where it is. And I think for us, that's the biggest driver.
Yeah, it comes back to the scarcity of people you can hire, and you've got to hire them where you can.
Yeah, and and how many, again, going back to fusion, how many people are there who can really do this, and where do they come from? Well, that's where you're going to be located.
Mm-hmm.
Yeah.
Yeah.
And to
Alex,
give-
we've got one final audience question, and then I
Yes.
think we're going to wrap.
First of all, thanks so much for the wonderful insights. I just want to ask probably a long question, like both from the technical perspective and also from an investment perspective. But please correct me if I'm just being ignorant. So I probably don't know too much about this. Like, first of all, would you mind just telling me a bit more about the current progress that's actually being made in the quantum computing space? I mean, we talked about deep tech for a while, but it seems that it's not inevitable that we will solve some of the very hard physics constraints problems that's actually constraining the development of quantum. Like Google's quantum supremacy seems to be relying on solving some very specific problems, and we haven't really seen the large scale promises that's been leading up to, like even generalized artificial intelligence hasn't been living up to that. And fusion, people has been saying this 5 more years, 10 more years for a long time. So that's sort of from the technical perspective. Would love to hear your thoughts on the actual incremental problems we're actually solving. And I guess that would be tied to the investing perspective, which is that, John, you keep saying this word, huge, we're going to have a huge market. It's going to be, some of the companies will be spectacularly successful, but like, how do you define huge or big? I mean, fusion is a big market. So like, how much of the legacy are you actually replacing? So it seems to me that a lot of the valuation today is very sentiment driven. You don't have revenue, so it's a huge market, but you don't really know. So we just keep pouring money in. And if I were an investor and I put money in fusion 10 years ago, 20 years ago, I would have terrible returns so far. Sure, this would be huge, but it's not just about time horizon. It's also the price level that you buy it in at. And it doesn't seem to be too great of a value proposition to me right now because of the hype and the challenges we see. So sorry for the very long question.
So let me just start with the first part of your question, which is, kind of where the state of the art of quantum computing is and kind of where does it need to go. I think that almost everybody who has built a quantum computer has built it according to what I would refer to as an academic model, where essentially it's like labware or benchware. And the question is, could you build a quantum computer? Can it run an algorithm? Can it do anything you can't do on a regular computer, on a classical computer? And I think the answers to the first two are absolutely yes. A number of companies have now built them. They can run an algorithm, and Google proved, and with some controversy, that you could do something on it that you couldn't do in a classical computer. That's different from asking the question of, can you design a quantum computer that scales to the complexity of a problem that's a high value problem that a large, corporate customer cares about and who's willing to pay a lot of money for it? That's a different set of questions. And so what we're building is an architecture that answers those questions. And we're doing it based on technology that we've already built, that we've built in the past for other applications. And we're now applying to quantum computing. So I would just say that we need to make that transition in the same way that we went from, the ENIAC computer in 1946 at University of Pennsylvania that was built out of vacuum tubes into something that you have in your pocket as, a powerful mobile device. We need to make that transition. We are at that point of making that transition. And at Seek, that is exactly what we are doing from a mission perspective and what our core technology is built around.
I think it's worth looking back in history as well. So if you go back to the 1920s before nuclear fission, we had no real expectation that we'd be able to create an atomic weapon or atomic power. And we did it in a far shorter time than we thought because of the spring up of the national labs and the huge amount of funding. So there needs to, but also fusion has taken longer. So there needs to be, we need to be humble around, what are the exact time horizons as you articulated. From my perspective, sitting across the quantum technology industry, what I can say is there's a lot that sits behind NDAs and closed doors, which is happening in the background, and huge advances at the fundamental manufacturing and research level, which gives a lot of people who are indeed biased in the industry a lot of hope that it's a lot closer than others are saying.
All right. Well, on that level of optimism around the future, join me in thanking Alex for hosting the panel and for John, Daniel, and John for joining us. As we mentioned, Pre-pandemic, we used to have weekly events like this at larger capacity. This is the first one in 25 months for us. And so it meant a great deal to have everybody back. Thank you to our panelists. Thank you for everyone at the Seek team for being involved. There are drinks and hors d'oeuvres here if you'd like to join up on the mezzanine level. Also, if you'd like to have a look around New Lab, I'm here and can take you around to show you. But thanks again for joining us in this return to normalcy.
Thank you.